Good morning, everyone. Welcome to Teledyne ISCO's September webinar focusing on vacuum versus peristaltic samplers, which is right for you. This morning's webinar is led by Stephen McMannis. He is our Senior Product Support Specialist here at Teledyne ISCO. If you have any questions or comments throughout the webinar, please use the chat function within the platform, and all questions will be answered at the end of the presentation. At this time, I'll throw it over to Stephen.
Good morning, everyone. As indicated, my name is Steve McMannis. I am the Senior Product Support Specialist here at Teledyne ISCO. And today I am here to discuss with you the variations between the vacuum and the peristaltic style samplers and how to determine which is the right one for you. Okay, there we go. There are a lot of decisions that one has to consider when making a determination about what instrument to purchase, and that helps you arrive and answer the question, which do I choose? It's not as difficult of a decision as it may seem. There are a variety of techniques out there for collecting automated samples, but the two most common technologies that you will see on the market are the peristaltic or the vacuum style samplers. A peristaltic sampler consists of components such as a controller, where one programs the sampler to make the decisions of when and how to sample, the volume, the frequency. It has the peristaltic pump, which is the method of actually collecting the sample. There are often liquid detection devices that will determine when the liquid has reached the pump to control and more accurately deliver the volume that has been desired to collect. You will have a strainer of some sort to prevent large debris from getting pulled into the line and restricting or blocking the intake. Of course, you have the suction line where the sample is transported from the source and delivered to the sampler. You will have stainless steel or other material couplings between the tubing. A pump tube that is routed through the pump, and the liquid detector is the tube where the sample is, collected by the pump. You will often have a bulkhead fitting that transports the liquid from above to below where the bottle is. You will have a discharge tube and may have a distributor arm if you're in a multiple bottle mode. If you're using a single bottle composite sampler, the tube will be delivered directly to the bottle. So how does a peristaltic pump operate? The cycle will begin with the rollers rotating as drawn here in a counterclockwise measure to blow pressure back down the line to clear any residual liquid that may have migrated up in the line since the previous sample event. When that is completed, the pump will change direction and begin to create a vacuum in the suction line to draw the sample up and deliver it to the bottle. Once the liquid detector has sensed that liquid has reached the pump, that is when the calculations take over based upon the volume you have programmed the sampler to deliver that accurate volume into the bottle below. Once it has completed the delivery of that sample, the final action is again to reverse the pump and purge out the liquid that has been pulled into the line and thus avoid residual material from collecting in the line and impacting the quality of the next sample event. What is a vacuum sampler? Well, similarly to the peristaltic sampler, there are various components that can make up the vacuum sampler. The pressure is controlled by a solenoid valve or vacuum, depending upon how that valve is switched. And it is similar in nature, where we have a controller, where again, the decisions are made of how that sampler is going to operate, the frequency of sample collection, the trigger for a sample collection, whether it be time or flow, the volume that's going to be delivered. There is a pump that is there again to develop the vacuum and the pressure. You will again often have liquid detection methods to determine when liquid has reached the chamber and to control the accuracy of the volume that will be delivered to the bottle. Again, you also have a strainer to prevent large material from being drawn into the intake line. And in the case of a multiple bottle configuration, there is a means to distribute samples to the individual bottles, or in the case of a composite bottle, the tube just drops the sample into that single bottle. How does a vacuum sampler operate? There are two primary methods provided by Teledyne ISCO. We offer a volumetric and a gravimetric option. The volumetric delivery method uses electrodes in the chamber to determine when the chamber is full, and then there is a tube that is adjusted to determine the amount of volume that is retained in the chamber and then delivered to the bottle. The initial portion of the volumetric cycle is that pressure is applied to the chamber and to the intake line to again purge out the line and remove any residual liquid that may have migrated up the line since the previous sample attempt. Then the solenoid valve changes direction, and now there is a vacuum placed on the chamber and the intake line to pull in the liquid. Once the liquid in the chamber rises to the point where it is in contact with the electrodes, the unit knows that now that chamber is full, and it will once again change the solenoid valve to again provide pressure to the chamber to push the additional liquid above and beyond what you've desired to deliver to the bottle, back up and out the intake line. Once that intake line is clear, it will open the pinch valve off and push the liquid down into the bottle where the samples are being collected. For the gravimetric or load sensor option, we use weight to determine and control the amount of volume that is delivered. What we see here is the front and the bottom view of that chamber assembly with the load sensor, and here is a side view. The first portion of the pump cycle for the vacuum sampler that is using the load sensor is it will zero out all the material, the chamber, and associated components to get a zero weight on that chamber. Then it will turn on the pump, and the solenoid valve is positioned to push and pressurize the chamber and the line to remove any residual liquid that may have migrated up the line since the previous sample. Once that is finished, the next stage is it will switch the solenoid valve and draw a vacuum in the chamber and the intake line to pull liquid in. Once the load sensor has detected that the weight of water that is in the chamber equates to the volume that you have configured the sampler to deliver, it will shut off the valve, switch direction, and purge out the line again. Once that purge has completed itself, it will then shut off the pump and do a verification of the weight of fluid in the sampler. The gravimetric style pump method is a continual self-calibrating device. So if it senses that there's too little liquid in the chamber, it will adjust the amount of water that it will deliver for the next sample collection time. Just as if there is too much weight in the chamber, it will adjust that delivery time, the vacuum, to reduce the liquid to get more accurate with each sample event that is collected. Sample accuracy on the gravimetric sampler is plus or minus 5 milliliters. Once the weight is delivered, it will again reactivate the pump and pressurize the chamber and open up the pinch valve to push the liquid down into the bottle below. Now, as with any technology, there are both advantages and disadvantages. The primary advantages of the Teledyne ISCO Peristaltic sampler, but not limited to, would be we are able to deliver very highly accurate volumes based upon pump revolution counter rather than runtime. We have a non-contacting liquid sensing device that is utilized to ensure consistent and accurate sample delivery. The pump performance in the liquid detection assures more consistent sample volume delivery across the full range of head lifts. As your water rises and falls, there may be variation in the lift that is required to pull the sample up to the sampler. Flexible programming options allow the user to configure that unit to meet their specific needs. The advantages of a Teledyne ISCO vacuum sampler, again, not limited to, again, we are able to deliver very highly accurate volume, especially at very small volumes. The Peristaltic sampler hits its sweet spot for accurate sample delivery when you're above 40 mils and especially above 100 mils. When it comes to the vacuum sampler, it can deliver very highly accurate sample volumes down as small as 5, 10, 15 milliliters. The pump performance of a vacuum sampler ensures more consistent line velocity over the range of lift, and that's important because that's going to allow you to have more representative sample, especially when it comes to solids, because if you have too slow of a line velocity, you won't pick up the solids at a representative rate. And if your line velocity is too fast, you can actually pull in more solids and elevate the solids representation in the bottle above and beyond what the actual quantity is in the source. The vacuum samplers have a very vigorous purge that more effectively clear the line of residual material and reduce the risk of cross-contamination between samples. And that is very important because one of the most important rules of any automated sampler is that the sample that it delivers to the bottle must represent the source. Additionally, the ISCO vacuum samplers have very flexible programming options that allow the user to configure that unit to meet their specific needs. So what technology should I choose? The most significant contributing factor that determines what to use often comes down to personal choice. A given user, a given regulatory agency, a given industry may have a preference of one method over the other due to standardization on one method over the other. Local agencies prefer one technology over the other, and they may stress the utilization of a peristaltic or a vacuum sampler. Regional standards have settled on one technology as the preferred method. For example, in the European theater, for the stationary permanent samplers, the preferred technology is a vacuum sampler. Here in the US, the stationary refrigerated samplers are often considered desired to be peristaltic samplers. So again, for example, 60% of the stationary applications in Europe are vacuum samplers. 95% of the portable applications worldwide are peristaltic samplers. In over 80% of the applications, either method are likely to perform equally well. But there may be certain characteristics of a given application need that lean in direction of one methodology over the other. The need for advanced functions and features are typically more important than the question of do I choose a vacuum or a peristaltic sampler. Features such as, do I need telemetry? Do I need remote access to that sampler? Do I have an application need where two-part programming would be advantageous, such as for stormwater? Do I need data logging? Do I have other peripheral devices connected to my system that are monitoring things like pH, DO, turbidity? Is that interface for those other parameters via an SDI-12 interface? And there are a variety of other application functions and features that may lead you down the road from one particular product over another. But there are some cases where the abilities of one of the sampling methods are more suitable than the other. And peristaltic samplers, they're obviously more suitable for portable application because the components of a peristaltic sampler are more robust and able to withstand the physical strain that a portable sampler is subjected to. A portable sampler is transported in the back of a pickup, back of the van. It's lifted up and down, sat, moved around, bumped, going down bumpy roads, and it's able to withstand that type of treatment. Quick maintenance. Replacement of the pump tube and suction line is a very easy and quick process in the peristaltic samplers. Pressurized line applications. You cannot, under any circumstance, use a vacuum sampler in a pressurized line application. There is nothing to hold the liquid back, so there's a free path from the source to the bottle. In vacuum samplers, applications that have significant head lift, greater than 23 feet, the line velocity in a vacuum sampler is not as negatively impacted, i.e. it doesn't slow down at lifts of 25, 26 feet like they do in a peristaltic sampler. Applications that have rather lengthy intake lines, greater than 50 feet. The more powerful purge is able to more accurately, more efficiently clean and clear residual material out of the line in a vacuum sampler compared to a peristaltic sampler. Lengthy intake lines are often seen in applications with hazardous rating requirements because folks will position the sampler outside of the rated environment and run the intake line from the location of the sampler and into the rated area. There is less physical wear and tear on mechanical components in the vacuum sampler due to lengthier run times because we don't have the mechanical parts in a vacuum sampler as you see in a peristaltic sampler. Requirements for collection of very small sample volumes. Oftentimes in a vacuum sampler, a customer will configure the unit to collect more samples of smaller volume at a more frequent rate. The accuracy of the vacuum samplers allows us to do that. There are options and features of certain vacuum samplers like our dual Optima, where you can have one sampler that is positioned between both an influent and an effluent, for example, and you can meet the needs of sampling from both those locations with a single unit. Applications that have noise restrictions or noise limitation requirements. The vacuum sampler is a quieter unit compared to the peristaltic sampler. And if we have needs due to noise restrictions that have been placed on that particular location, the vacuum sampler will be more able to meet that need. So with that, I would open the floor to questions. And so we're going to pull up the questions here and let's see what we got.
as we wait for questions to come in, Steve, are there any other areas where you would say that the difference between the two would make a deciding factor?
And again, in most cases, as indicated, both units are most likely to perform equally well. One of the reasons, or one of the the factors that I will do on a frequent basis when someone's calling me is I will ask questions to try to find out the details about the application, things like what is the material that we're sampling, what are the lengths of the line, what are the lifts, what other peripheral devices will we be integrating with the sampler, are there needs for, again, things like telemetry, do we need add-on devices for different parameter monitoring, and try to get that picture built. And based upon the answers to those questions, generally speaking, you will be able to very easily narrow down the desired selection to one or two options. As indicated in the presentation, there are application conditions that certainly would rule out one technology over the other. Something like a pressurized line application would rule out any vacuum sampler option right out of the gate. If we have the needs for very small volumes, that would lean the scale in the direction of the vacuum sampler out of the gate. Portable applications. Again, I stress that portable applications really lend themselves to the peristaltic samplers. For those of us who remember the old 70s commercials for Timex, the peristaltic samplers, they take a beating and keep on ticking because they can take that type of physical, rough treatment and hold up. Okay, the first question here. Do we have any model examples of peristaltic samplers and vacuum samplers? Absolutely. ISCO has a variety of options within our product portfolio. An example for the peristaltic sampler families, we would have models such as our GLS portable sampler, composite only. We would have our 3710 and 3700 portable samplers. Those are a little more elevated sampler model. They have greater flexibility and capability than the GLS. Then for portable samplers at the top end, we would have our 6712, which is our full-blown top-of-the-line sampler, SDI 12 interface, modem capability, data logging, the ability to add on 700 series modules. For the refrigerated models in the peristaltic, we have our 6712FR, which again is our top-of-the-line refrigerated stationary sampler option. Has all the same capabilities as the portable 6712, the SDI 12 interface, modem capabilities, data logging. And then we have our 5800 sampler, which has the ability to interface with flow meters if you want to do flow meter, flow pace sampling, or you can do time pace sampling as well. For the vacuum sampler models, we have our stationary vacuum sampler options in the Optima, the Premium, or the Dual. And we have variations within those product lines. We have the ability, again, to do the volumetric or the gravimetric sampling. You have the ability to configure for both single or multiple bottle. And those are all whether indoor or outdoor units. We have the Century 3000, which is an indoor refrigerated sampler for the vacuum sampler. And again, that has the ability to be configured for single or multiple bottle. The longest horizontal run recommended for both types. For the peristaltic sampler, the lengthiest line that you can configure for is 100 feet. There are tricks that you can go beyond that, but generally speaking, we don't recommend that because of the amount of wear and tear that the pump tube would be subjected to, and you're going to be doing frequent pump tube replacement. Mathematically, you can go up to about 300 feet with the vacuum samplers. And then there's a secondary question there. What would I select if I have heavy grit? There's various shades of gray to that question because there's some measure of subjectivity to what heavy grit means. But in a peristaltic sampler, heavy grit, when it gets pinched by the rollers, will have a derogatory effect on the pump tube over time. And you're going to have need to more frequently replace that pump tube because it will degrade as a result. So if you have a heavy grit application, I would tend to lean in the direction of a vacuum sampler. Okay, if external batteries are the only option to power the sampler, which sampler requires more power to operate? That's not an easily answered question because much of that question hinges upon how we program the sampler. What's the length of line that we have on that sampler? The pump in a 6712, when it does operate, will draw more current while the pump is running. But if I'm only taking one sample from a 10-foot suction line once an hour versus having a GLS, which the pump draws less current, but I have that GLS set on the line that's 50 feet long, and I'm collecting one sample every 5 minutes, the GLS over the long haul will draw more current. So the real answer there lies in how am I going to program the sampler. Now, the 6712, as indicated, has the ability to have more peripheral devices added to it. So if you have a 6712 with a modem, with a 700 series flow module, with an SDI-12 SOND interface happening, the ongoing current draw with that unit will be high even if the sampler is not collecting samples. So the real secret to that, to answer that question, is how do we intend to use it? I have a peristaltic pump that just replaced a vacuum sampler. The intake is 60 feet long with 12-foot lift. The intake time between the vacuum compared to the peristaltic is the same. Should the vacuum sampler have been replaced with another vacuum sampler in this situation? Not necessarily. The big issue there, the big bottom line is the peristaltic sampler delivering the outcomes that you desire? If the answer to that question is yes, and if the same question were asked to the vacuum sampler and the answer to that question was yes, it comes down to which one did you prefer? And then it becomes to the other peripheral issues that come to the table that may tip the scale one way or the other. Does the peristaltic sampler that you have the features and capabilities that are more suitable to the application and sampling routine that you need to offer compared to the vacuum, or vice versa? So that's the area where that question may actually tip the scale one way or the other, not necessarily based upon the pump performance and the sample performance alone. Do you have any refrigerated portable samplers? Any that will fit into a manhole? The easy way to answer that question would be yes and no. We do have portable refrigerated samplers. We have our Glacier single bottle sampler, and we have our Avalanche multiple bottle sampler, but they would not fit into a manhole. They are simply too large. Most commonly, application-wise, those devices are used in remote applications where there is need for active refrigeration, but there is no active AC power source, and so therefore the utilization of a deep cycle marine battery, oftentimes some of those applications will be permanent, even though we're using a transportable refrigerator where they will set up a solar panel battery system to maintain constant charge on the battery for its ongoing sampling needs. The multiple bottle variation is the avalanche, and that will be often used in stormwater applications, where you would have a rain gauge, you will have potentially telemetry, a modem, you will have a battery. At times, if it's a permanent application, you will have a solar panel where you're awaiting the trigger of the sampler into operation based upon the detection of a certain amount of user-defined rainfall. The cost of parts and skill set requirements for the vacuum sampler maintenance versus vacuum samplers are drastic. Solenoids and electricians are expensive to maintain. Vacuum versus pump tubing is cheap. Potentially, if you're in an application where you have material that has the tendency to build up and thus require more frequent maintenance to clean, would be one of those conditions where I might lean in the direction of a peristaltic, because as the question states, it's fairly easy and quick to replace that pump tube as opposed to have to break down the components of the vacuum sampler to clean. On the other hand, if you're in an application where you do not have that constituent that is going to more frequently foul the pump tube and the chamber, the vacuum sampler may in the long term have less maintenance requirements, because regardless of what material we're sampling, the pump tube will eventually physically wear out and require replacement. So again, that comes down to understanding the application conditions that the instrument will be subjected to, and then you could utilize that information to discern whether I would be better off going the route of a vacuum or a peristaltic sampler. The next question, would it be preferred to take more samples of less volume or less samples of more volume? That really comes down to, the user's requirements, the regulatory requirements that they are trying to meet. In some cases, the regulatory requirements demand more frequent samples of smaller volume. When that, dictate is laid in front of you, that overrides everything that you as a user may prefer, or that I as a manufacturer may prefer. I personally have an approach of more middle ground. To me, a very suitable collection frequency is on average 4 samples an hour, 96 samples a day. I think in most application conditions, that's going to get you a very representative sample. Some people might want to go every 5 minutes. Some people may want to go every hour. There's a measure of user's choice in there. I will say that there does come a point where the frequency of the samples will definitely tip the scale in the direction of the vacuum sampler. Because if I'm going to collect a sampler every 1 minute, I'm going to be replacing that pump tube in that peristaltic sampler very frequently. Whereas if I'm taking a sample every 1 minute in the vacuum samplers, there is not going to be the same degree of wear and tear on the expendable items, i.e. the tubing, and therefore the maintenance needs are not going to be as intense. The question is, in hot weather, ice melts within a few hours at most here. I'd like to find a way to keep my industrial wastewater sampler at the correct temperature during collection. There's a lot more behind that question in of itself. It doesn't indicate whether this is a permanent or portable. The fact that we're using ice does tend to lead me to believe we're talking about portable applications. There are certain things that one can do in a portable application to aid the sampler and slow down the melting of that ice. One suggestion that I've found over the years that has fared very well is, instead of using liquid ice, water ice, packing gel packs frozen gel packs in and around the bottles. The same gel packs that you would use to keep your 6-pack of beer cold in your cooler. They have greater cooling capacity. They will hold up longer, and at the end of the day, you don't have the mess of all the residual water from melted ice to have to deal with. You just pull the gel packs out, put them back in the freezer, and chill them back down. Avoid setting the sampler in direct sunlight. Give the sampler every advantage that you can. And the way to think of that, if you have 2 coolers with a 6-pack of beer, and you put one in the middle of an asphalt parking lot and one in the shade of a tree for 4 hours, and then you can't have anything to drink for that 4-hour period. After that 4-hour period, which one would you want to have the beverage out of? The one that's underneath the shade tree is more likely to have cooler beverages. So, try to do things to help the sampler out. Again, I do recommend consideration of gel packs to elongate the ability of that to cool the sampler.
Okay, the question is, we have disconnected the top of the avalanche with a connector for one of our customers so that will fit in the manhole. If I understand the question, it means that we've removed the control head from the top of the avalanche. I would be interested in seeing where we positioning the refrigerator, et cetera, et cetera. However, in most cases, I would not recommend doing something of that nature just from, at least without checking out all the details. So that's a question I'm not able to really answer with a great degree of knowledge, simply because there are more questions I have about what's going on there.
Okay. Well, thank you everyone for taking some time out of your morning today to discuss the different types of samplers. If you have any further questions or comments, Steve's contact information is up on the screen currently, or you can reach out through the email sent to you for this webinar. Either way, we look forward to continuing the discussion. This webinar has been recorded, so it will be shared with all attendees afterwards, and it will also be available up on YouTube on the Teledyne ISCO page later on this week. Thank you so much, and have a great day.
Have a great day, everyone.